Good afternoon from Toronto. My name is Janice Turner, and it's my pleasure to welcome you to today's webinar. We have over 2,500 registrants. I would like to acknowledge Robert Half for sponsoring this presentation. For more information, go to www.rhi.com. I will now pass it over to Kevin Johnson, VP Robert Half Management Resources, to introduce today's speaker.
Hello, everyone. My name is Kevin Johnson. I'm the Regional Vice President of Robert Half Management Resources. It is with great pleasure that I introduce you to today's speaker, Dwayne Burgonye. Dwayne is a CA with an IT specialty. He is President of BAI, Burgonye & Associates Incorporated, and is internationally known for his candor and practical expertise in implementing document management solutions using Caseware's working papers as the foundation for the unpublished documents within a public accounting firm. And now I'm going to pass it off to Dwayne. Thank you very much.
Thank you very much, Kevin, for your kind introduction. Good day to everyone. I'm Dwayne. And today I'm going to try to attempt to simplify the concepts that are now commonly referred to as cloud computing. But before we start, cloud computing is not a new concept. There's only a new terms being applied to existing concepts. If you've ever used Google for a search, or wrote an email via Hotmail or Gmail, if you've ever accessed your firm's workstations from your home, then you've used cloud computing resources. So today, the cloud. We'll talk about what is the cloud, how the perfect storm allowed for the emergence of the cloud, what types of clouds are out there, what cloud services are being offered, and finally, we'll see that the future belongs to the computing grid. So in the beginning, we had a standalone PC. And so the user could view on their display, and they could input data and their processing choices via keyboard and mouse. So let's not make it more complicated. We had viewing and input devices that transferred information to and from a machine. The computer, the standalone computer in this case, was the servicer of all computing services, software, processing, and storage, to name a few. Users don't usually care where the software or the processing or storage is located. They simply want the service to be delivered whenever they need it. Thus, we started with what's referred to as on-demand computing services being delivered from a single standalone unit. This has been around for a long time. So then came the server. And the concepts of the server was that we were starting to share computer resources. We started to share printers, and then we started to share data storage locations. And so local area networks and file servers were introduced. The user's video display and input devices were still right in front of them, and they were used for interacting with both the local machine and or from a distant file server. Once again, users didn't care where the software, the processing, or the storage was located. Users simply wanted the service to be delivered whenever they needed it. And thus we continued with on-demand computing services as server-based technology kicked in. So now we're in this environment that they refer to as the cloud. If we were to apply a minimalist sort of approach to describe what cloud computing was about, it's really just extending your video and your input cables to anywhere our internet cabling goes to. It's that simple. No more and no less. Users really don't care where the software, the processing, and the storage is located. Users simply want the service to be delivered whenever they need it. So we're truly starting to enter an age where we have on-demand computing services being delivered from anywhere at any time. So, what is the cloud? Well, I guess, this is a professional organization. We have to start with some sort of definition. We can argue about the benefits of Wikipedia, but presently Wikipedia's definition states that the cloud computing is the delivery of computing as a service rather than a product, whereby shared resources, software, and information are provided to computers and other devices as a utility, like electricity grid, over a network, and typically the internet. Okay, then, why is this simple and very clear concept becoming this? No wonder many of us are still confused or still foggy on cloud computing. It's because shared resources, software, and information over a near or a far network is very complex. So we're being introduced to a whole bunch of different disciplines, technologies, and specialized terms for a multitude of steps that happen in this very complex world. Keep it simple. So let's take a hint from Google Earth, and let's zoom up or out and remove some of the details so we can focus more clearly on the core concepts. So first, today we're not talking about different audit standards or reports that are available for service providers or data centers. And these include SAS A16, SAS 70, SOX 2, and SOX 3. So let's remove them from the equation. In fact, we're not talking about the different expressions for where the computing services are located. So let's remove the terms service providers, data centers, and hosting services. Okay. Now let's remove some older or non-cloud specific terms like wide area networks or local area networks or application service providers. And at this level, we don't need to talk about the different connection application approaches. So let's remove virtual private networks, secure virtual private networks, and remote desktop protocols from our discussion. There. This is much more manageable. The only thing is, let's herd these concepts together into three groupings so that we can see them a little more clearly. There. Here's some focus. We have types of clouds that are available, service options for cloud services, and why cloud computing is such a hot topic right now. Let's start with why cloud computing is such a hot topic right now. In October 1991, a storm stronger than any in recorded history hit the coast off of Massachusetts. It's now universally known as the perfect storm. Most of us know it from the Hollywood movie of the same name. What made this storm so extraordinary was the fact that the energy from three distinct systems, a New England frontal system, Hurricane Grace, and a storm off the Great Lakes, combined to create an energy system whose outcome was an energy system that greatly exceeded the sum of the energy from each of the storms. In the computing world, virtualization, SAN technology, and internet bandwidth increases have come together to provide the so-called perfect storm, creating enough energy to create cloud computing. So, let's take a look at these concepts so that we understand what they're about, so when we hear the words, we know what they're talking about. Let's start with virtualization. Virtualization is definitely the catalyst that enabled cloud computing. Next to the deployment of the internet itself, I personally believe virtualization is the second most significant step in the evolutionary ladder of desktop computing. And while I assume you've heard of the word virtualization before, it's a difficult thing to describe. So let's see if we can clear up some of the fog surrounding the concepts of virtualization. We're going to use a simple analogy here. The analogy is not perfect. However, I trust it will help in explaining virtualization. We're going to talk about a home, which is a place you live in, and the concepts of a house, which is a structure for the home. So what we're talking about here is the words home and house. For most of mankind's history, a person's home was his house, or I could say their house was their home, so to speak. They were used interchangeably. There was a one-to-one relationship between talking about the home and the house, remembering, of course, that the house was the structure. When you needed a service like electricity to your home, you pulled a cable to the house. So each homeowner had to be knowledgeable with regards to many services that the home used. And so the homeowner was comfortable with the house's electricity, heating, plumbing, etc. Now, in our IT world, in our standalone world, we had one user to one system, and that system provided all services. Then we started to build many homes together. Another way of saying that is we built many houses with tight spacing. Note that so far we're still using home and house interchangeably. The main reason we did this was to share common resources. It was now easier to provide shared resources like electricity and water supply and sewage. Roads were much easier to build. The mail delivery became much more efficient. We still maintained to a large degree a one home to one house. However, we started to network them together, so to speak. In our computer world, this is akin to the evolution of the local area network. We still had one user to one system relationship, but we started to share file services, backups, etc. Then someone, at some time in our history, must have thought, why not build that home above and not beside the rest of the houses? In the language of the analogy, you now have many homes sharing one very large house or high-rise structure. Now, this must have been truly evolutionary. I mean, it seems common sense to us now, but it created a multitude of advantages from shared resources as the structure only needed one connection to the electrical grid. But it also started to provide previously unknown advantages. Heating was much more efficient. We have now the concepts of the military security by taking the high ground. Each homeowner no longer had to be knowledgeable with regards to many or all of the services that the home used. So items like electricity and heating and plumbing, they became a shared resource. And it had a shared management service. We no longer use home and house as interchangeably as, say, my grandparents did. So, virtualization. Virtualization has removed the direct one-to-one connection between a server, which delivers computer services like file sharing and print redirection, with a single hardware computer box. In today's world, my home can be situated in an extremely well-serviced condo, a place with concierge service, a spa with a pool and a sauna. I can have fiber optics communication and enhanced air filtration and fire prevention systems and emergency power supplies and the best of the best mechanical engineers for maintenance issues. My home's life standard of living can be substantially higher by placing my home within one of these advanced infrastructures. Thus, virtualization. I can take my server, the provider of computer services. Remember, this is not the server hardware, but rather the server as the software structure, and place it into a cloud-based machine. The next system to contribute to the perfect storm that created what is now known as cloud computing is referred to as SAN technology. So let's take a look at storage area network. A SAN is an intelligent device that is dedicated to writing or retrieving data transferred from multiple servers. So now we have the concept of having many servers accessing intelligently one hardware storage device. There is no question that so far this is the most significant infrastructure advancement for storage technology. Previously, the individual server controlled writing and retrieving data, allowing it to flow where it was needed, but the server also performed all of the other computational responsibilities, like keyboard processing, video displaying, internet communications, and on and on. So, let's try an analogy to describe the significance here. Let's use the concept of a toll booth that controls traffic access on and off the highway. In a non-SAN environment, the toll booth operator, the server, is multitasking. The toll booth operator is granting access on and off the highway, but also performing many other tasks. A little silly, but let's suppose they're also providing directions or using the window for fast food ordering. Traveling from point A to point B would be painfully slow because you're always being queued for processing. The SANS removes the multitasking from the server and focuses only on the on and off access functions. So imagine an electronic toll booth. The queues at the toll booth are removed. You simply travel on and off the highway without delay. The processing of all traffic from all on and off ramps is simultaneously handled. The processing efficiencies of a SAN can effectively utilize the vast and inexpensive disk storage available in today's world. It's amazing how large a space we have now. It allows for enhanced, redundant array of independent disks, RAID technology, a way of storing data redundantly on multiple hard disks so that we can provide ever-increasing levels of confidence on the future availability and accuracy of our data, and still accelerating processing speeds. Perfect storm continues with the third. The final source that combined cloud computing is internet bandwidth. Now, the word bandwidth is the concept of how much information can be sent between two locations. Most locations in Canada are experiencing improved internet transmission speeds from all internet infrastructures. We're increasing speeds in telephone, and cable, wireless, cellular. In fact, most communities across the country support bandwidth speeds that provide smooth YouTube playback, even with 3G cellular networks. In a cloud computing environment, keyboard keystrokes are sent to the virtual workstation. Processing is done at the virtual workstation, and then the video display is sent back to the user. Remember, we simply have video, input, and sound. The local location, all computing services, as we described earlier, are being done wherever they're being done. Therefore, only keystrokes, video, and possibly sound require internet bandwidth. And video changes take up the bulk of the bandwidth. Video changes. How the software changes on your screen. One of the most demanding bandwidth applications to watch is smooth video playback. But we have that. You can watch YouTube. Most small to medium-sized enterprises can now get affordable internet bandwidth to watch these videos, which means that they are also able to support infrastructure as a service delivered applications like Caseware or Tax Prep or Microsoft Word or Microsoft Outlook, as these applications only refresh their displays periodically. And much more is just around the corner. Across the entire country, the existing copper or cable infrastructure is being replaced with fiber, which will allow for internet bandwidths that are 100 times faster than currently possible. Already, in many places, you can receive or transmit video as fast as your eye can process it, with sound as fast as your ear can hear it. So the energy from the three storms, virtualization, SAN technology, and internet bandwidth have come together all within the last few years. Their combined strengths allow the evolution of cloud computing as a utility to be offered to us. Small to medium-sized enterprises now have access to the best possible infrastructure that this infrastructure is so outrageously expensive it would always be beyond their means. Now we have computing utility companies that are starting to offer these to us within a similar framework as the public utility company. You simply pay for what you use. And for all practical purposes, there's no limit to what you can use. Just use what you need today. Excuse me. So let's take a look at the types of cloud computing that is available to us. And let's use the electrical grid as a background analogy. First, we have a private cloud. So, technically, if you have access from your office's local area network from your home or a client site, then you most likely have a private cloud in place. I started my presentation by saying these aren't new concepts, just new terms that we're using. Many of us access our company's resources from our home or from remote sites. A private cloud is when you own all the infrastructure. That is, 100% of the infrastructure is in your control. This is the concept that all of your electrical service is being delivered only from your own generators. Now, back 100 or maybe 120 years ago, this would have almost been the norm for most businesses that needed electricity for their processing sites. Because at that time, the utility grid just wasn't, it was just in its infancy. It just wasn't practical to rely upon it. So the private cloud is presently the norm. And so many of us refer to it as accessing our wide area network or accessing our Citrix services. However, the private cloud will slowly fade away. There are not many businesses now that own their own electrical generators. If they need more electricity, they simply use more of it. As to a large degree, electricity is being delivered as a scalable service to almost everywhere. And as the infrastructure improves, so our computing utility will provide the services that we need on demand. Public clouds are then the opposite extreme. This is where a third party supplies all computing services to you. This is the electrical grid as we know it today. You simply plug in and use whatever amount of electricity you need. Don't use it for days, and then you need vast amount of it, no worries. It's completely scalable for you. You simply pay for what you use. You plug in to where you want it. You use as much as you need it. You don't really care how it's created or how it's delivered. You just want it on demand. In public clouds, you connect from your office or from your home or from anywhere. All computing is really being delivered to you remotely. The concept of my computing device will be no different than my lighting device. If I carry my lamp to any location and plug it into the electrical grid, I want the light to shine. If I carry my computing device to anywhere and I plug it into the computing grid, I want computing services on demand. In today's world of tablets, much of the computing services is being delivered from public clouds, with only some very basic local application really being applied on the tablet direct. My wife uses her iPad to primarily surf the web, but she reads online magazines. She browses and updates Facebook. She types emails to her friends. These are all public cloud deliverings. I say again, the concept of the cloud is not new. We've been using it all the time. It's just we're being introduced to new terms to define them. Public clouds are owned by someone else. We use the services that are being delivered on demand. So this brings us to the combo pack, the hybrid cloud. A hybrid cloud is where you own your own private cloud, and you also have the use of public clouds. For the electrical grid analogy, this is where you are plugged into the grid. However, you have to supplement your electrical needs with on-site generators. Now, as far as the analogy with electricity, don't confuse this with owning your own generator for emergency purposes. In the analogy, this is where you are supplementing the electrical grid electricity services delivered because it cannot provide enough electricity, or it is not reliable enough to provide enough electricity for the specialized electrical services that you need. So you now have to get a little far-fetched to think of these situations. However, it might be a mining operation in a rural, not a remote, but a rural community. They don't have access to the electrical grid all the time, but they have it most of the time. But the electrical grid can't service enough to support all of their electrical needs. And so they have an on-site generator to supplement the electrical grid's supply. As a general statement, in an electrical grid environment, this is seldom used today. However, at the infancy of the electrical grid, I would have imagined this was a relatively popular starting point. And thus, in our computing grid, you have your own local area network. to access it from a remote and thus become a private cloud, and to access public clouds as well, is a relatively common starting point. So a hybrid cloud would exist if you do maintain your own network, if you allow access from remote sites, and you're using products like Microsoft 365 or Salesforce CRM products. You're accessing email through your Gmail or Hotmail accounts. So we've talked about virtualization, bandwidth, SAN technology, and why these three came together as a perfect storm to create the cloud as we're seeing it. And we've taken a look at the three different types of clouds that are forming out there, and how they're using the term as private cloud for your own owned and 100% controlled environment, and a public cloud for infrastructure owned by others, and a hybrid cloud, which is really the real world for most of us today. So now it's time to look at the services that cloud computing can offer us, and just as importantly, how these services are being managed. Let's start with software as a service. Now, in the marketplace, I've heard this said as a SaaS offering. This is where the software is delivered on demand. Now, a huge advantage to a SaaS, or software as a service solution, is that the vendor provides all maintenance of the application, including all version updates and all data conversion. So on my Gmail map, I have my home as a site that's saved. I don't care when the next Google Map software update takes place. It's handled for me by the software as a service provider. And it still maintains the location of my home. So this isn't as unusual as you first might think. We use SaaS, or software as a service, at a lot of our websites. It could be as simple as an amortization calculation on a banking site. It's definitely all of the free stuff that we see out there, like Gmail and Hotmail. But there are also pay-for-service environments. One of the ones being pushed right now is Microsoft Office 365. Now, most vendors, application vendors that is, are either in the process of offering a SaaS offering, or they're skirting around trying to get one to the marketplace. A SaaS offering makes sense when the application, and more importantly its data, does not need to be retained or interact with any application, because the application and the data are usually maintained at the software as a service location. So we also have platform as a service. This is being offered, as a cloud service. So this is where the software and the infrastructure resources are delivered on demand. Platform as a service offerings can be free, or they can be, a pay-for-use environment as well. Now, think of your website host provider. They're providing you a location where they're providing the infrastructure and the platform in order for you to deliver your web pages to your clients. I'm of the opinion that Facebook and LinkedIn fit into this category, as they're providing a self-contained infrastructure. So you can go to that location, you can read messages, and you can look at pictures, and you can watch videos, and you can update or upload any new content, and you're using all of their applications. All of it is just the way the platform defines that you're allowed to do these things. In both a platform as a service and software as a service environment, the service provider provides all managed services for us. I never have to worry about making sure that the newest version of the video playback on my Facebook is updated. It's handled for me by the platform as a service environment. So, this finally brings us to infrastructure as a service. This is probably going to be the one service that affects us more and more over the next short while. If any of you have already used Microsoft's terminal server, some of you might know it now as its new name, a remote desktop server. Or if you're using Citrix server, then you know what? You already are working in an infrastructure as a service environment. Infrastructure as a service is where, in essence, all of your computing equipment and software, so that is, all the servers, all the operating systems, all the applications, all the databases, all of the computing services are hosted off-site. The distinct difference between infrastructure as a service and platform as a service is that the end user controls all aspects of the infrastructure. Okay, that's a little bit of a mouthful. So, with infrastructure as a service, if your server needs an update or an upgrade or a security patch, it's your responsibility. You're in control of it. That's the advantage of infrastructure as a service. You need a new application to be installed, go right ahead. You can install a new application on infrastructure as a service environments. You can't on platform as a service environments unless they allow you to. I can't go to Facebook and upload my own video playback system, but I can go to my own infrastructure as a service and do that. So, it's your server with infrastructure as a service. The infrastructure as a service provider doesn't manage the complete infrastructure offering. But almost all infrastructure as a service providers normally partner and offer managed services to you so that you do not have to handle these aspects. And then that brings us to managed services. Now, software as a service almost always includes managed services. I very seldom have ever seen it. In fact, I might not have ever seen it without managed services. Platform as a service always includes, to a large degree, almost all managed services. I've never really seen it offered separately, although they provide some flexibility. Infrastructure as a service is offered simply as infrastructure as a service. However, almost always it's offered with their managed services bundle. But it's a separate bundle. And so the managed services provider manages either some or all of the components of your infrastructure. And those components are, of course, both the hardware and the software component. There's no question managed services are pay per use. There is no free managed services being offered in the marketplace as a standalone service. Now, it can be bundled into a whole variety of different product offerings. They definitely will include virtual server configurations and monitoring, updating and adjustments. They'll include operating system and application installs and configuration and updating. And they'll include data recovery systems and just about anything that you would like managed for you within that infrastructure or software environment. We looked at how the perfect storm of virtualization, SAN technology, and internet bandwidth energized and then created or allowed the creation of cloud computing offerings. We've seen that the clouds can be privately held or publicly held or some of both with hybrid clouds. And we've seen the basic different services being offered: software, platform, and infrastructure, as well as the concept of paying for managed services. Combine the three independent evolutionary technology advancements and you have a perfect storm that's changing the landscape of computing forever. And I firmly embrace and believe this. Now, the small and medium enterprise can benefit from shared computing power, data storage, and delivery systems that would just be absolutely outside of their range of affordability. Managed services are provided by expert, focused, well-trained professionals. You can benefit from being dynamically scalable, extremely agile. You can have fault tolerance. And most importantly, you can have all of this without any true capital investment. It's a simple pay-per-use cash outlay model. So all investment costs are borne by the provider of the service. And these services are run in state-of-the-art data centers with 24/7, 99.997% uptime, and they supply complete business continuity and disaster recovery solutions. I visited one of these data sites. It is amazing. They have a gap between the outside solid concrete wall so that if a vehicle smashes through the wall, it falls into the gap and can't even touch the platform that the equipment's on. It has raised floors to, in today's world, the highest standard now is 48 inches to ensure no flooding can touch the infrastructure. Redundant grids from the electrical grids. Your practice simply buys the server power you need, and as you process increase, you simply ask for more processing power. And the provider simply upgrades your virtual servers with a click of a button. This includes everything from hardware to software licenses for your services to many of your applications. You receive an invoice for the monthly services used and delivered, and you pay for what you use on demand. Not only do you see an easy, even monthly budgeted cash commitment, you can also experience considerable cost savings as well. I've heard of anywhere from 20 to 40% total cost of ownership and maintenance savings that are available in this environment. Henry Ford is credited with saying, if I had asked them what they wanted, they would have asked for a faster horse. It's a cute saying. So, this is how it all comes together. We have the office, we have the home or remote location, we have a data center. So the office. Presently, many of us are replacing costly PCs and office local area networks and file servers with much less expensive thin client desktops and notebooks. A thin client. A thin client is a device that provides the service of connecting to the internet. Remember in our simple, I need connection to my internet so that I can have video and input devices. So my thin client provides me with input devices like, of course, my keyboard and my mouse and USB connections so I can upload or download data, and they require very little, if any, management. There's no huge Windows operating system on it. There's no antivirus software. There's no updates required. There's no application configuration needed at the workstation level. And they save about 80% of the PC's desktop power consumption. You'd be surprised at how much money you're actually paying for the electricity used by your desktop. You simply connect your thin client to the internet, turn it on, and then start to work like you always have. You don't really care where the computing services are being delivered from. Users simply want the service to be delivered wherever they need it on demand. So thin client at the office is starting. Now your home. You can connect with either a fully loaded PC or with a thin client. The reason you might have a fully loaded PC at your home is that you may want additional computing services that are not being delivered by the company's cloud computing services. Now the same decision is required for remote locations. You may not need a full-blown notebook in the field. You may use a thin client notebook. That is, providing you can get a connection to the internet, and you don't really need to maintain a full-blown PC. Go with thin client notebooks. And now the data center. So finally, we, the small, medium enterprises, have removed the concept of having to deal with all the infrastructure, all of its maintenance, all of its update, all of its protection. No need, really, for us to worry about firewalls and climate control and web filtering and fire suppression and controlled access and redundancy and failover and backup and 24/7 uptime and physical security and on and on and on and on. We simply turn it all over to the cloud access service provider. And they look at it for us and for many, just like my condo provides me with a better home standard lifestyle. Now let's take a look at the electricity grid. Is it really the same? My office, my home and remote, and my electrical utility. The bottom line is that we, the users, don't really care where the electricity source comes from, nor do we really care how it's made or how it's delivered. We simply want the service to be delivered anywhere or anytime and on demand. There's no question in my mind that mankind is truly entering the age where the computing grid will be supplying all computing services into the future. So the question comes down to, now the time to connect to the grid. Now first, it's no longer a bleeding edge approach. And it is still a leading edge approach to some degree. But it's easy to connect to as if you can connect to the electrical grid. So if you can connect to your internet and get enough bandwidth, then you can have that as an option. So if your internet speed is available to you and it's fast enough that you can, then you definitely are a candidate to join on to computing cloud services, today. There was a time when all of a sudden the electrical grid took over from on-site generators. I don't know when that really happened, but it probably happened when people, started to face the concept of investing in new generators. In some way, if you're investing in a new computer infrastructure, or if you're going to change the supplier that currently manages your technology, at the very least, consider looking into the cloud and an infrastructure as a service with managed services options. Then decide on whether the cloud, i.e. infrastructure as a service offerings, will give you the greatest benefit. Remember, it's really the computing services that you are buying. You're more than willing to pay for those services because that's the way we work today. So whether that service is delivered from an on-site server or from a cloud provider, it really comes down to a cost-benefit decision. Thanks. And now what we'll do is we'll ask if we have any question and answers.
Yes, please continue to use the Ask a Question at the bottom of your screen. Now, the first question that has arrived is the security of the cloud good enough to comply with the Privacy Act?
That's a twofold question. First, I have read the Privacy Act. One of the concerns about the Privacy Act in its summary is that whether the data is being saved on a physical location in Canada and therefore it's subject to the Canadian laws and thus the Privacy Act. So that if you're going to be transferring your data outside of your privately held environment, a private cloud, and transferring it to a public cloud, first ensure that it's on data soil. Now, if it isn't, then the Privacy Act, of course, provides for that, and you can then notify your clients that you will be maintaining their data outside of the Canadian environment and deal with the consequences of that. But the security question is really the twofold is the privacy cloud, yes, on physical soil, Canadian soil, and the second is the actual security concepts of getting at that data. There's no way that a small, medium enterprise could ever have the security that these data centers have. Now, in the real world, for me to tell you that data centers are absolutely secure would be silly. But to say that wouldn't take hackers much to break into your own firm's privately held security with its firewalls and that would also be silly because most could. And so, security. Data centers provide you with the best possible physical and operational security that you have. Privacy Act. As long as the data is being saved on Canadian soil, that's your first level of concern. Thanks.
Okay, so what is the risk of using an unsecured public network such as Starbucks to access your cloud files from Dropbox or SugarSync? Can someone intercept your files and take copies without you knowing?
Yeah, there is no question that that can take place, and so that, I mean, the concept of today's presentation wasn't to get too detailed with regards to connection, but you can have secure VPN connections like Juniper that would therefore encrypt items as they're sent through the cloud. That would, of course, exclude the concept of using a publicly available, Wi-Fi sort of environments. Common sense dictates a whole bunch of things. If I'm sitting in my Starbucks, I also should probably have a privacy filter on my screen so the person next to me can't see my screen and see the information as well. So there's many things that we need to consider in the computing age and be aware of, and there is a practical side of surviving in the computing age and working in it.
Okay, next question. What guarantee do you have that your data will be recoverable in the event of the bankruptcy of the service provider?
Wow. That's probably the one that hits the nerve the most. I got no guarantees. Now, you can provide for that. The only thing I can tell you is, I mean, if the company does go bankrupt and their assets are seized, I would assume that the law will be on your side and you will eventually get your data. But for most of us, our data is our assets, our production cycle, it's our livelihood, it's our revenue stream. We can't just assume that we can park things for 6 or 8 months and go through a legal hassle in order to get access to it. However, when you are signing up for infrastructure as a service provider, then address these concerns with them, because there are logical ways of handling that concern from a practical environment. It could be a reverse backup. It could be that you simply are taking a backup of your data, because you have access to your data, to your local environment, to a local backup environment, or to a local drive, and you do that periodically. It could be that within your contract, they will deliver to you data that will then be at a certain interval. Every week you'll receive a copy of it, et cetera, et cetera. So the only thing I can say is negotiate this as part of your contract. But they probably provide better data security than you can with regards to access to your data. Now, I'm not talking about somebody coming in from the outside. I'm talking about what happens if a fail-safe environment, your server goes down. The typical story that you hear all the time is in most people's file room location, there's a sprinkler right above it. So if there's a fire anywhere on the floor, your file server is probably the first thing that's going to fry. So be aware of it, address it, like any contract.
Okay, can you provide examples of the major cloud providers in Canada?
I'm sorry, I cannot. I mean, I'm aware of many, but we don't follow the any indices that would really be able to rank them according to how quickly they can provide you with services, what their ranges would be, their financial security environments, the stability, their service, managed services, and how well they do that. So I'm sorry, no, I can't provide you with a listing.
Okay, using IaaS, is it possible to retain your data locally while using services in the cloud?
Well, you could, but I wouldn't recommend that. That's not the concept of infrastructure as a service environment. I mean, I refer back to my earlier question or an answer with regards to, keeping local access to your data for emergency purposes so that if you have some sort of problem with the infrastructure as a service provider going bankrupt. But if you're going to be sending data back and forth across the bandwidth of the Internet, it's going to be killer. And so the true efficiency gains are where you're only really sending video, sound, and input, keyboard back and forth. All processing, all data travel is being done remotely at the virtual location, and so that's the way I'd address that.
Okay, so how does one go about determining the level of security of a service provider?
There's a series. I addressed it very quickly with some of the words earlier. I mean, we have SOC 2, SOC 2, SOC 3, SAS 70. There are certain assurance levels with regards to data center providers. The only other thing is, like any other service, contact their clients, ask them for referrals, and follow up with them. Don't just assume that because they say so or because they provide you with a client name without you contacting them that they're as good as they say they are. Now, most of them are good at what they do, otherwise they wouldn't be sustained in business. However, I do have a gut feeling that over the next 5 years or so, this will be a little bit of an easy exit environment. Now, not an easy entrance. There's huge costs to do the initial investment. So yes, follow up with their clients with regards to how their managed services are, how well they're updating their infrastructures.
Okay, you mentioned SMEs many times. What about the feasibility of the cloud for large organizations like governments with their sensitivity over confidentiality and security of data?
Well, the larger the organization, the more the cost factor starts to be equal. Whether you actually have an infrastructure as a service provider provide you with huge infrastructure services, or whether you purchase these and maintain them yourselves, it becomes sort of a line that eventually joins in the very distant horizon. The smaller the environment, the greater the leverage you have off of the investments that are taking place. And so that I'll leave it at that right now.
Okay. Can you comment on the security during the transmissions between the cloud and the source?
Yeah, the cloud and the source, like I said before, there's, I throw out Juniper, it's probably the most known one. There's all kinds of secure VPN ways of handling that where it's encrypted and it is secure. No concerns with regards to the Privacy Act. Now, remember, this is the real world. There is no thing as absolute, but the point is it's a very, very tight, recognized encryption, secure connection technology.
Okay, so how do you keep local backups?
It depends on how you arrange it with your infrastructure as a service provider. Like I said, I've been aware of some of them that they actually have in their contract that they'll take a backup onto a USB device and physically ship the USB device to on a regular interval. The other is you have access to your data. You can download your data. You can upload your data. Think of your local environment when you have a local workstation and you're accessing your server. Anyone at the local workstation that has access to all data on the server could download all that data to a local environment. The constraint will be the throughput or the bandwidth available to download that on a regular basis. And so for practical reasons, it's not really practical to maintain that data on a day-to-day backup sort of environment, but it is practical to do that on a periodic sort of basis.
Okay, what are the main disadvantages of using cloud computing?
The new. Probably the hardest thing for all of us as we keep migrating into the new technologies is feeling comfortable with it, investigating it, making sure that we are taking the proper steps at the proper time. Now, I openly say this to anyone that listens to me. I'm a firm believer that God didn't give us fear so that we don't advance. He gave us fear so we don't die. And so if you're a little bit leery about entering into a cloud computing or an infrastructure as a service environment, then advance slowly. Make sure that you're doing due diligence as you go, but don't stand still. Now, you're only standing still if you're not forced to do an infrastructure as a service investment in your own private cloud. Translation, if you do not have to invest in your own server with major dollars, then don't make that decision point now, but always compare it with the outside. Do it with due diligence. There's no question in my mind that in X amount of years, 10 years or less, most of our computing will be through what I'm referring to as the computing grid.
Okay, are there service providers who provide all the software services, or is it necessary to contract with various providers for each service?
That's a tough question. I'm not sure how the future is going to shake out. With software as a service providers having expert managed services on their specific application, with the concept of collaboration, emerging so that we can collaborate with data amongst many applications, so that we can get structured content, reports and documents out of more than one software source. That's all part of the future. But the only thing I'm going to mention right now is the cloud is definitely the way that we are migrating towards. Keep your vision towards it. Be aware of it. Step forward, as you can, and these things will kind of shake out as it is. However, if you're asking me the question about managed services and whether, let's say, I work with lots of public accountants. If I'm a public accounting firm, should I watch which infrastructure as a service provider I should go with regards to their managed services? Then, without question, go with someone that is boutique. Go with someone that is, has several clients in the public accounting arena, that is used to the applications and the peculiarities of those applications within that industry sector. In today's world, specialization gives us huge advantages. And so that find your tribe, as Seth Godwin would say, find the people that, can service and manage your specific applications that are aware of them rather than a generalist as such out there.
Okay, in light of what happened with the RIM last week, should we be concerned placing so much reliance on a third-party service provider?
I don't know. I'd say the same thing about electricity. I'm old enough to have lived through the blackout that took place 10 years ago, and so what am I supposed to make sure that I got some sort of generator in my house that I can connect with my bike? That's a very unusual circumstance. You and I both know it. It was very unfortunate, for the BlackBerry users to experience that sort of outage. So no, we cannot embrace in today's world a competitive environment and still protect ourselves from those small little things that can happen in the real world.
Okay, what will happen to all IT personnel when you switch to the cloud?
They're going to get better and better, because they won't just be sitting around trying to pretend to be IT specialists. An IT specialist will be with an infrastructure as a definitely give them the proper training and invest in them correctly, we'll have the best of the best IT. We won't have people that pretend to know IT or do their best at trying to deal with IT because your firm doesn't have enough capital to continually send them out on updates and upgrades or give them an area of specialization because they have to be a generalist. And so that I believe it'll work something like our physicians or our doctors are now. That we'll have great need of people that can bounce around the firms and provide them with general, but we will definitely now have the distinct opportunity to have specialists available to us that can handle the specialized needs of our IT, very specific environments.
Okay, can caseware working papers be used in the cloud?
There's no question that it can be. There's no question I've seen it being used in many clouds. Now, when we say the cloud, I assume you mean infrastructure as a service, so that you're actually being hosted 100% off-site in a virtualized environment, whether it be an RDP session or whether it be a Citrix-based session. And again, I've seen that in both environments. So yes, it can be. But like any application that really runs in a local environment, there can be hiccups with regards to it, and that's why your infrastructure as a service provider, if they're a specialist or you work with many firms in the same industry sector, will have hit those small anomalies that take place no matter if it's actually off-site or on-site that you're running that service.
Okay, regarding ERP software application, is it specifically designed or altered for cloud computing?
Well, ERP environments, most of them are definitely migrating very quickly into a software as a service environment to begin with because of the complexity with regards to updating the application and converting the databases that are maintaining, the data for, the application. So most of them are already either offering or are already in the SaaS or service as a software solution environment.
Okay, if a software is unavailable on the cloud, you still need a local PC, correct?
Well, there's no question about that. If you need specialized needs, you still have to handle it in a specialized environment, but now you'll have choices. So you small, medium-sized environment, I don't care, pick a number, you've got 30 to 50 people in your environment, you may not need to maintain as big of a file server as you did before if most of it's off-site and you only have the odd application. It may be a better cost-benefit analysis to actually just load it onto 2 or 3 workstations that need the application rather than having to configure it for all users through the server. And so it's like anything else, there's lots of variety, lots of advantages to having these specialized applications, and then we configure them accordingly.
Okay, can we set up individual client access for separate clients, for example, shared QuickBooks file access within the clouds?
Well, I'm going to avoid the QuickBooks specific reference here. The concept of being able to provide the security for different end users is without question available to us in any sort of a cloud, whether it's a publicly generated cloud or whether it's our own private cloud, our own file services environment. And so yes, it's going to be the application that's going to run it. It's going to be the security, the firewalls, the location. I mean, all those are normal considerations. These are general IT questions, not specific necessarily to the concept of cloud services.
What is the cost for the on-demand services?
Well, we're back to on-demand services are really what you are required, what you require to be delivered on demand. So in my world, where we work with, public accounting firms, again, somewhere 100 or less sort of at a local environment, maybe offices, more locations, those environments, like I said, are experiencing somewhere between a 20 and a 40% total cost of ownership decrease when they migrate to infrastructure as a service provider. Now, the total cost of ownership is the investment with all of your hardware, the maintenance with regards to them, the update with regards to them, and all of the manpower costs, all the wages in order to make sure that all of those are available to you on site. And so that I can't give you any more than that. There are many IaaS providers out there that will help you with the total cost of ownership calculation, a true one based on what you're presently experiencing and what you could experience through a infrastructure as a service provider.
Okay, we have time for one final question. Have there been any legal cases as a result of data not being protected?
I don't know the answer to that. I've not become aware of anything. That doesn't mean that it exists out there. But that question would hold true with regards to, your own server. I mean, take a look at some of the stats with regards to the hackers and how many servers they've actually hit. It's very unlikely that your server, if you're a firm of any substance, has not already been hacked at least once. And so, yes, we have to be very aware of those items. In my house, in my business, there's no question I have locks on my doors, but I have not included yet shatterproof window glasses because the cost just doesn't justify the benefit to me yet to restrict access. So also with regards to all IT environments, I don't believe the infrastructure as a service is actually less. I think infrastructure as a service is probably provides you with greater levels of assurance that the data is not being accessed in an unauthorized way.
Okay, well, the fog has certainly cleared for me regarding the cloud as a result of your presentation, Dwayne, so thank you, and also to the rest of the audience for participating in today's webinar. And I would like you to please take the time to complete the evaluation located in resources, since your feedback is very important to us. Thank you.
And thank you.